In this section, we will look at some problems involving functions. This is again one very important question type for CAT, XAT, IFT, these kind of exams, and we should understand the basic methods really very well. The first question for us, f of x plus twice f of minus x is equal to 3x plus 2. What will be the value of f of 10? In order to solve this question, what we can say is, if f of x plus twice f of minus x is given to me, if I replace x with minus x, I would be able to form two equations involving f of x and f of minus x. From there, I should be able to find a general formula for f of x. So just bear with me. Replacing x with minus x, I will get f of, okay, originally I have got f of x plus twice f of minus x is equal to 3x plus 2. Replacing x with minus x, I will get twice f of x plus f of minus x is equal to minus 3x plus 2. From here, because I am interested in the value of f of x, let us multiply the second equation by 2 and subtract the first equation. We will get 2 to the 4, 4 minus 1, 3. So 3 into f of x, 2 minus 2 will cancel, is equal to 2 3 is 6 minus 3 is minus 9x. 2 to the 4, 4 minus 2 is 2, so minus 9x plus 2. So from here, f of x is equal to minus 9x plus 2 divided by 3. We are asked to find the value of f of 10. Put this is equal to x equals to 10, minus 90 plus 2 minus 88, minus 88 upon 3 is your answer. So that was the first question involving the concept of looking at the relation between f of x and f of minus x. Let's take one more example. Something similar, a similar concept will be used there also. This time we have been given f of x plus thrice f of 1 upon x is equal to 2x plus 1 upon x. We have to find the value of f of 2. In order to solve this, what we will do is, this time we will replace x with 1 upon x. If I replace x with 1 upon x, I will have two equations in f of x and f of 1 by x. We can remove f of 1 by x, we will get the value of f of x. So replacing x with 1 upon x, I will get 3 times f of 1 by x plus f of x, 1 upon x, sorry, f of 1 upon x is equal to 2 upon x plus x. Because I am interested in f of x, I will multiply the second equation by 3 and subtract the first equation. 3 3 is 9, 9 minus 1, this is f of x actually, this is f of x. So multiplying the second equation by 3, 3 3 is 9, 9 minus 1, 8, 8 times of f of x, 3 and 3, this will cancel, this is equal to 3 2 is 6, 6 minus 1, 5 upon x plus 3 minus 2, 1, so plus x. From here, f of x is equal to 1 by 8 into 5 upon x plus x. X is given as equal to 2. If I make x equals to 2, this will become 5 by 2 plus 2. This is equal to 9 by 2. 9 by 2, 8 to the 16. This is equal to 9 upon 16. That is your answer. Next question. It is based on a slightly different model. We are given that f of 1 plus f of 2 plus dot 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 till f of n is equal to n square f of n. If the value of f of 1 is given as 36,000, we have to find the value of f of 8. There can be two ways of going about this question. One is that we could try to form the general pattern for this series, and once we are able to form the general pattern for this series, from there we try to determine what will be the value of different terms. A second method could be, we could do some substitution here, and with that we are able to find that general series. What we are going to do is, from here, if f of 1 plus f of 2 plus dot 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 till f of n equals to n square f of n, would it be fair to say that f of 1 plus f of 2 plus dot 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 till f of n minus 1 will be equal to n minus 1 whole square f of n minus 1? Now from here, if I substitute this thing here, this will be f of n minus 1 plus f of n plus this is equal to whole series. So substituting till f of n minus 1, I will get n minus 1 whole square into f of n minus 1 is equal to n square f of n plus f of n. So this will become minus 1. So from here we get f of n upon f of n minus 1 is equal to f of n upon f of n minus 1 is equal to n minus 1 whole square upon n square minus 1, which is equal to n minus 1 upon n plus 1. Once we have this, let me bring back my f of n minus 1 from here. So f of n is equal to n minus 1 into upon n plus 1 into f of n minus 1. Now because I know f of 1, f of 2 is equal to 2 minus 1 upon 2 plus 1. So this is equal to 1 by 3. F of 3 will be equal to f of 2 into 3 minus 1, 2 upon 4. F of 4, 4 minus 1, 3 upon 5. F of 5, 5 minus 1, 4 upon 6 into 5 upon 7. 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. F of 7 will be 6 upon 8. F of 8 will be 7 upon 9. So we know the value of f of 1. Substituting this, we'll get the value of f of 8. So from here, as we can see, 3, 4, 5, 6, 7, this will cancel. 2, 2 4s are 8, 4 9s are 36. So 1 upon 36 into f of 1. F of 1 is 36,000. 36,000 upon 36, 1,000. So this value is equal to 1,000. That is your answer. Next problem, let us say we are given f of x is equal to 3x cube plus 2x square plus x plus 1 upon x plus 2 upon x square plus 3 upon x cube. We are asked to find the find the value of the of this expression f of 2 upon f of 1 by 2 plus f of 3 upon f of 1 by 3 plus dot 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 till f of 9 upon f of 1 upon 9. Because we are looking for f of 1 upon x, let us see what will be the value of f of 1 upon x. Here, if I replace x with 1 by x, what I will have is f of 1 upon x is equal to 3 upon x cube plus 2 upon x square plus 1 upon x plus 2x square plus 3x cube, which means that the value of f of 1 upon x is also same. If f of 1 upon x is also same, naturally f of x upon f of 1 upon x will be equal to 1. If f of x upon f of 1 upon x is equal to 1, that means that each of the terms in this expression is equal to 1. How many terms are here? 2 to 9, 8 terms in all. Because there are 8 terms in all, their sum will be equal to 8. Answer. Next problem, we are given f of x equals to 4 to the power x upon 2 plus 4 to the power x, and we have to find the value of the expression f of 1 upon 97 plus f of 2 upon 97 dot 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 till f of 96 upon 97. What we can observe here is that if I look at this and this, 96 upon 97 is nothing but 1 minus 1 upon 97. Because this is f of 1 minus 1 upon 97, it makes us wonder, we probably need to find the value of f of 1 minus x. If we find the value of f of 1 minus x, then this and these terms, we may be able to combine them. So let us see what is the value of f of 1 minus x. This is equal to 4 to the power 1 minus x divided by 2 plus 4 to the power 1 minus x. This is equal to 4 upon 4 to the power x multiplied by 2 plus 4 upon 4 to the power x, which is equal to 4 to the power x, 4 to the power x will cancel, 4 upon 2 into 4 to the power x plus 4, which would mean that 2 can be taken out from here. This will become 2, this will become 2. Now if I observe f of x and f of 1 minus x, if I do a f of x plus f of 1 minus x, this is equal to 4 to the power x upon 2 plus 4 to the power x plus 2 upon 2 plus 4 to the power x, which is equal to 2 plus 4 to the power x upon 2 plus 4 to the power x, which is equal to 1. If this is equal to 1, so from here I understand that this plus this will be equal to 1. Second term, second last term will be equal to 1. So two terms, they can be combined. Overall, how many terms are there? 96. 96 upon 2, 48. So overall 48 such pairs will be there. That will be your sum. Answer is 48. Next question. We are given f of x equals to twice f of x minus 1 for all values of x, where x is an even number greater than 1, is equal to thrice g of x minus 1 otherwise. So which means that x is an odd number. G of x is equal to twice g of x minus 1 for all x which are even numbers, and is equal to thrice g of x minus 1 otherwise. The value of f of 1, g of 1 is given as 5. We have to find the value of f of 6 into g of 6 into f of 3 into g of 3. It would be appropriate for us to look at f of 1, f of 2, f of 3, f of 4, f of 5, f of 6. Similarly, g of 1, g of 2, g of 3, g of 4, g of 5 and g of 6. F of 1 is given as 1, g of 1 is given as 1. F of 2 will be because x is even, so this is equal to twice f of 1, so f of 2 is 2. Similarly, g will be twice of g of x minus 1, so this will also be equal to 2. F of 3 when it is odd is equal to thrice g of x minus 1, so f of 3 will be equal to thrice of g2, so this becomes 2 3 is 6. Similarly, g of x is thrice g of x minus 1, that means that this will also be equal to 6. F of 4 is twice of f of x minus 1, so this becomes 6 2 is 12. Similarly, this will be equal to 12. This is equal to thrice of g of x minus 1, so this becomes 12 3 is 36, and this is also equal to thrice of g of x minus 1, so this also becomes equal to 36. And lastly, f of 6 is equal to twice of f of x minus 1, so this becomes 72. This also becomes 72. So we have all the values, f of 6, g of 6, f of 3, g of 3. Multiply, you get your answer. Next example, we are given that f of x and g of x are quadratic functions. F of 2 equals to g of 2 equals to f of 5 equals to g of 7 is equal to 0. F of 3 equals to 5, g of 4 equals to 3. We have to find the value of f of 8 into g of 8. What we will do is, if f of 2 and f of 5 are both equal to 0, that means that these are the two roots of the equation f of x. If these are the two roots, then the general form will be, let's say, some constant k multiplied by x minus 2 into x minus 5. Similarly, in the case of g, well, let's say the constant is L into x minus 2 into x minus 7. This is the general form of the second expression, so that if x equals to 2, this becomes 0, x equals to 5, this becomes 0. There is some constant k by which it has been multiplied. Using the third condition, we would be able to find the value of this constant. Now, if f of 3 equals to 5, let me put x equals to 3 here. 3 minus 2 is 1, 3 minus 5 is minus 2. This becomes minus 2 into k is equal to 5. So, k is equal to minus 5 by 2. Similarly, on this side, g of 4 equals to 3. 4 minus 2 is 2. 4 minus 7 is minus 3. Minus 6 into L is equal to 3. So, L is equal to minus 1 by 2. Now we simply substitute these values here. So this is equal to minus 5 by 2. This is equal to minus 1 by 2. We have been asked to find the value of f of 8 into g of 8. In order to find the value of f of 8 in g of 8, simply substitute x equals to 8 and you are done. So overall the value will be minus 5 by 2 into 8 minus 2 is 6, 8 minus 5 is 3, minus 1 by 2 into 8 minus 2 is 6, 8 minus 7 is 1. Multiply, this is your answer. Next we have got a quadratic function f of x, which is the maximum value at x equals to 1, and this value is equal to 3. F of 0 is equal to 1. We have to find the value of f of 10. What we understand is a quadratic function is of the form ax square plus bx plus c. If the function is of the form ax square plus bx plus c, if f of 0 is equal to 1, that means that c will be equal to 1. Next, this function has a maximum or a minimum value at x equals to minus b by 2a. If it has a maximum or a minimum value at x equals to minus b by 2a, that means that this is equal to 1, and this value is 4ac minus b square upon 4a, so that will be equal to 3. Now c is equal to 1, so c will disappear from here. I have got two equations in the form of b and c. So from here b is equal to minus 2a. Substituting that here, I will get 4a minus 4a square upon 4a is equal to 3. 4 3 is 12, 12 minus 4 is 8. 8a is equal to minus 4a square. If 8a equals to minus 4a square, 4 2 is 8, a and a will cancel, so a equals to 0, which does not make sense, or a is equal to minus 2. If a equals to minus 2, so from here b is equal to plus 4, so b is equal to plus 4. If a equals to minus 2, this becomes minus 2 plus 4. We have been asked to find the value of f of 10. So for f of 10, 10 square is 100, 100 minus 100 into minus 2 is minus 200, minus 200 plus 80 is plus 40 is minus 160, minus 160 minus 1 minus 159. That's your answer.